Okay, guys, I had to sadly end that live stream because for some reason my bitrate literally got down from 1000 kbps to 0 kbps. I mean, I have no idea how it did that even happen. My Wi-Fi connection was even fine. I was like so confused at that time, so I had to literally check this out, and even my OBS was not even responding, so I had to literally close this whole thing down, and I had to literally make another live stream for that. So I deeply apologize for that. Anyways, I did English, by the way. While I completed English, I actually noticed that this was actually not working. So yes, I'm gonna continue with this. I hope so. This does not happen again, because this did not happen actually. Like, yeah, OBS has crashed for frequently. Like, it has crashed many times, but then this thing was kind of, it wasn't even responding. It was like, the bitrate literally went from 1000 to 0, even though the Wi-Fi connection was fine, and even I don't know how did that even happen, but OBS literally is not responding. Then there's another window of OBS opened which I cannot even close. I don't know why. I don't know why I cannot close this. Does not allow me to close. I don't know why. What's wrong here? I have no idea. But anyways, guys, you're gonna start with chemistry now. We're gonna revise a bit. Okay. Hmm. I see. Okay. Hmm. Let's start off. Actually, no, I have his contact saved up, so you cannot actually see his number. I know, it looks kind of weird not showing you the number, but then sometimes you cannot just trust the people. There are like 10,000 to, this live stream is of course going to public, so if anyone sees this, they have the probability or the capability of literally, breaking out of that box and like doing anything that's gonna go crazy. So yeah, we cannot trust humans actually. I'm so sorry, guys. Sometimes I cannot even trust myself. Let's not waste time. I'm gonna take my chemistry now. We're gonna revise a bit of more equilibrium. Tomorrow we'll learn extra additional new topics in equilibrium, because tomorrow is a holiday. If you don't know, we have field trip tomorrow, but I'm not going there because whenever I think of field trip, I always think it as a chance for me to study as I got a free day. Anyways, I don't want to waste my time. My test paper, I have written my productivity skill, so let's erase that part where I have written this. I should have written, no, I think I should not have written this in pen. But I mean, no, it's written in pencil. I mean, it's fine. But if it was written in pen, then I would have been like, going crazy, because I don't have a whitener around me. Maybe my mother has, because she is a teacher. She uses lightener, but I don't know whether I have it or not. So yeah. let's do chemistry rev, or in other words, chemistry revision. So for equilibrium, we have overall learned that there are two types: static equilibrium and dynamic equilibrium. The concentration of the reactants remains the same as they do not react at all. That is known as static equilibrium, as there is no reaction going on in the system. Whereas dynamic equilibrium, which is the equilibrium that we are going to study in this chapter, is the basically the concentration of the reactants and products being constant, such that the rate is basic of forward reaction is equal to rate of backward reaction. We get to know that equilibrium only takes place in reversible reactions. Then dynamic equilibrium are of two types. What are those two types? Physical equilibrium and chemical equilibrium. Sorry, is it? Uh, Property of a substance and physical equilibrium. Okay. So physical equilibrium is basically kind of an equilibrium process that does not have any chemical change involved in it. Of course, I still remember learning physical change and chemical change. Changes around us. That one chapter in the NCERT was one of the main reasons where we get the idea of physics and chemistry. That's the introduction of chemistry and physics, by the way. So, yep. And then physical equilibrium, we actually have the idea of of what kind of physical equilibrium we are having. So there is two types: the phase transformation, and the second one is the dissolution of the solid or gaseous states into the liquid. Sorry, when there are dissolution of solid and liquid. Solid and gas in liquids. So yes, we have known about these. So first of all, let's go deep and make a deep dive based on that. So for physical equilibrium, we have phase transformation. That is this changes in the state. Those are solid liquid equilibrium, liquid gas equilibrium, gas solid equilibrium, and yeah, I think that much. Suppose solid H2O gets converted into liquid form of H2O. That is basically saying that rate of fusion, that is the forward reaction taking place. Actually, no reaction takes place. It's a physical process. That's fusion. Fusion takes place. That rate of fusion is equal to the rate of freezing. Why? Because suppose I take my temperature at 0 degrees Celsius. You know that it is also known as the melting point for ice and freezing point for water. So therefore, if I actually have 0 degrees Celsius, it will be remaining at equilibrium. Therefore, yes, blah blah blah. I'm yapping so hard that I'm literally have my eyes closed up. Not gonna lie. If you don't know, actually, I'm gonna close my eyes right now. Then we have so okay, after solid liquid equilibrium, we have liquid gas equilibrium. This is also known as the equilibrium, where suppose we take water, that is a liquid state, of course, and room temperature is converted into a gaseous form. That is the boiling point of the water. So we can say that rate of evaporation is equal to rate of vaporization. Is that correct? No, rate of condensation, my bad. Because vaporization means the same thing for evaporation. That's why. And condensation is basically converting gas into liquid. So rate of evaporation is equal to rate of condensation. That is in the equilibrium state, by the way. And if I talk about sublimation this time, that is the solid to gaseous state, which means, like, suppose I take camphor solid, that gets converted into camphor gaseous state, then I would say that the rate of sublimation is basically equal to the rate of deposition, meaning that deposition is a process where gaseous gases directly get converted into solids without even involving to become in liquid states. So that's what we need to have an idea based on that. So after that is basically dissolution of solid and gases in liquids. And if we talk about this one, solid and liquids and gases in liquids, yeah, let's turn the page for now. We can say that sugar, which is in solid state, I have poured more and more and more sugar, which makes it very, very saturated, super saturated, in fact, that it does not even dissolve it. So I can say that there are crystals forming up, right? Yes, I can say that crystals are forming up. So rate of crystallization is equal to rate of dissolution. Yeah, I forgot about that. Rate of dissolution is equal to rate of sugar. Sorry, rate of dissolution is equal to rate of crystallization. Like, suppose you're gonna put sugar in water. So, sugar in water is basically wait a minute. Okay, so sugar and water. This is one of the basic solutions we know in our lifetime. That we are learning through our lifetimes, and wait a minute, guys. Ouch, ouch, ouch. That hurts. Ouch, that hurts. Ouch, ouch. I don't know what happened. Okay, equilibrium, huh? So, anyways, as I was saying that we can also have gases being diluted into the liquids. That is also possible. So let's put an example for that too. Like we know that we actually had drank some soda. Soda is a kind of thing which is basically sugar water, of course, but with carbon dioxide, which is acting as a carbonated water, meaning that water is and carbon dioxide are together forming a solution, and that is a homogeneous mixture, by the way. So um, these two make together the main complex stuff we need to know. And also, if we there is one thing we need to know. There is an expression for that. That solubility of gases is directly proportional to the pressure, and solubility of gases is inversely proportional to the temperature. And this is given by the Henry's law that we mainly study in class 12 of chemistry, first chapter solutions. Then what else do we have to get the idea of? Yeah, there is a question because I had to look at the note because there are some questions that I have to go through that are actually theoretical, like the soda water questions, and then we have the chemical process one, which I have to revise basically. I mean, there's not much to revise, but yeah, we know that there's mainly a lot of stuff we need to talk about here. Now, soda water bottle is sealed under pressure. Why is it so? Because the more the pressure, we know, the more the carbon dioxide will get dissolved into the sugar water. Meaning that basically we are just applying the application of Henry's law here. By doing that, we actually got this correct. So, what is Henry's law, by the way? Like, what am I actually even discussing about? So he actually stated that the partial pressure of the gases is directly proportional to the mole fraction of the gas. You know what's mole fraction? Mole fraction is basically the number of moles of the solute of that component, not solute, of that component divided by the number of moles of the solution. Of okay. So the one component of solution could be solute or a solvent. That's why I actually said component, because it can also include solvent too. It does not only include solute. Oh. Chi it is also represented by a letter X actually, but then it is known as chi, not X actually. So partial pressure of gas is directly proportional to mole fraction of a gas. Then what else do you want to know? Oh yeah, I did not complete this, so let's write this. Mole fraction. Soda water water when left in the air turns flat. 5. So basically, what do you mean by turning flat? The soda water is basically, having that burning taste. Whenever you actually drink, you feel a bit of burning inside your mouth that goes on. Basically, that's carbon dioxide being present in that solution actually. So what happens is that once you shake it off, what happens is basically when you shake the wait a minute, guys. Yeah, when you shake the soda, what happens basically is that the kinetic energy is a lot, of course. and that results to be like having a lot of temperature too. So whenever you release that, literally a lot of carbon dioxide gets released, and that from that it turns flat, right? So that flat taste you get, you will not feel that burning feel. You will not get that burning taste because of the flat because of the soda bottle or anything like Coca-Cola, Pepsi, and any other stuff. They actually don't give that burning taste when they turn flat. So basically the question is, what happens when why does the soda water when left in the air it turns out to come flat, turns out flat? Oh my god, my English is becoming a bit cringy here. My bad. I should not actually make my English more and more cringy. I should make it much better and improve my own self. Yeah. And if you'll see, I am a bit tired, but does not mean that I will stop, of course. We're gonna continue again and again and again, right? So, of course, we're gonna do physics lecture, by the way, just after completing this. So that, like, we don't have any delays going on. The physics lecture will be the longest one yet, because then next one is bio one, because bio will also take a lot of time. I swear it's gonna take us a lot of time, but I think it will be worth it. I'm not gonna give up for sure. Oh my god, I feel like I should have taken a power nap, by the way, because I feel so dizzy and weird. I'm not sure whether I can even survive the night without even sleeping a bit. Oh shoot. Like, since there are holidays coming up, I can actually, like, become a night owl, night owl. My bad, not all night. You know what do you mean by night owl? Basically, a student that studies overnight, even surpassing the midnight, is known as the night owl. Okay, night owl. So he's known as that title. But then there's another one known as early birds, who actually study very early in the morning. I mean, very early in the morning is also fresh and fine. Depends upon the person who does that. Oh, yup. As I was saying, soda water can. Okay. Wait a minute. I'm not sure what's the answer of this question. I'm trying to read it and understand this, so that I can learn it. This question is interesting though. I like it. Wait a minute, guys. Just wait a minute. I'm not sleeping, but I feel very sleepy. I swear. Shoot, dude. Oof. soda water can be sealed under pressure, of course, and this will actually lead to the dissolubility of the carbon dioxide in water. However, when it is kept open, open, in which it is in contact with the air, the CO2 escapes out, and therefore the pressure gets lowered down. So basically, the soda bottle gets turns flat, and solubility also decreases. Solubility of gas and liquid, or solid, no, gas and liquid, decreases when wait a minute, let me think. Don't worry, guys, I'm right here, I'm not sleeping. But yeah, it's getting crazier and crazier. Equilibrium in a chemical process, so let's study that. So, the chemical process of an equilibrium, we actually get to know that there is a chemical change taking place, meaning that the substance gets changed from one side to the other side, meaning that this reaction that takes place is not actually for unidirectional, it's bidirectional, meaning that it is a reversible reaction, forward reaction, and backward reaction takes place. The concentration, okay, if I explain this, in the beginning, the concentration of the reactants is maximum, and therefore we can say that the rate of the reactants to do a reaction will be also maximum. However, after a time period, we actually observe that the concentration of the reactants is actually equal to the concentration of reactants. This means that it is at an equilibrium state, and the total rate will become zero. So that's what we need to have an idea based on that, meaning that the concentration increases, but due to an increase in the concentration of C and D, after that we can also say that the concentration of C and D increases, where the concentration of what's backward reactions, right, rate of backward reaction also increases along with it. So we have to get an idea based on that. Oh shoot, dude. Wait a minute, guys. Just wait a minute. Ouch. Okay. Sorry for the big delay. I have also created a post saying that basically I actually wanted to test something. I wanted to actually do something that is for basically for the video, and it will take time. It may take you on next month, but yes. So sorry for that. And overall, I think this is actually greater enough to have this as the delay. I'm so sorry again. I will still continue. I'm not sure how long I'll continue. Maybe more than 10 minutes. But let's do it. I knew it. I have to end it.